Okay, son, so we're going to be going over a case that comes out of systems of linear equations. And the case or problem is this. You're given a bunch of points. You have to determine whether that point is on both of those lines or only one of those lines. If you plug in the values and you find that point is on both equations, then that's a solution. If you find out that one number is, or one equation is, but the other doesn't satisfy the point, then there's no solution. So it has to be all true. Okay, so we look over here. And again, we're given a point here, -8, -4. We want to know if it satisfies or it's on both of these linear equations right here. So we start off and we plug the -8 in on the first equation. Then we find out at the end that 16 equals 5, which we know is false. So automatically, this is an ordered pair to the solution of the system. So we go over and plug the -8 into this one here. And again, this is true, but both of these have to be true for it to be an ordered pair and to be a solution. Okay, so we go down here and we plug in our -3, and we notice that 5 equals 5, so far it's true. This one right here, we plug in our -3, and we get the equation 4 equals 4, so that is true. So this is an ordered pair that is on the system. Remember, they have to all be true. They have to satisfy both of these equations, that value is, for the ordered pair to be a solution. If one of them is false, then it's not an ordered pair. Now, you'll still have to plug in both values. I'm sure your teacher will expect that. But okay, so we go to these right here. Get close. So -1, 3. We want to know, is that point on both of these lines? So we plug in the -1, and right away, when we solve, we get 16 equals 1. So it's false. So remember, in reality, if 1's false, the whole thing is false. It's not an ordered pair. Over here, we plug in the -1 and we find out it's true here, but again, it doesn't matter because this was false. They have to be cool with both of the equations. Okay, so when we plug in that 0 for our first equation, -7x plus 3y equals 1, we get false. And over here, when we plug in 0, we get false again too. So we know that there's no way there's going to be a system or a solution. They have to both be true to be a solution. So we plug the -4 and the -9 in. When we plug the -4 into the first equation, we get 1 equals 1, so that's true. When we plug it into the second equation, we get -9 equals -9, so that's true. And then we do the 2, 5. Looking at it, we automatically know it's not going to be a solution, but your teacher wants you to work it out anyway. So when you plug in the 2 on the left side, we get 1 equals 1, which is true, but on the other equation, 4x plus 7, 5 equals 15, which is false. Okay, so same thing here. We have the equation 9x plus 3y, -9x plus 3y, and 3x plus 5. The first thing we do is we plug our x value in, and when we plug it in here, we notice that it's false. So the whole thing is going to be false. But we still have to work it over here, and since we're plugging in the 0 on this side, we notice right away that -5 can't equal 5, so the whole system is false. And the same thing down here, the -4 and 1. So we have to plug our -4 in. When we do that, we get 39, which we know is not equal to 15, so that's false. And then when we plug the -4 in here, we get 1 equals -7, so that's false. Remember, for it to be a solution, they both have to be true. If one of them is false, then it's not an ordered pair. And obviously, if both of them is false, it's not an ordered pair. So the whole go with these problems, to recap, is this. You're given two linear equations that are on the same system. Then you're given a set of values. You plug in, for each point, you plug in the x values to each equation. If both of them, if your solution here is true, and the solution here is true, then the ordered system is true. Here we plug in 9, and we get 36 is not equal to 7, so we know that's not true. Then when we do 9 over here, we find out that 3 equals 3, so that's true, but only one of them counts. If we look at the -4, -9, the same thing. If we begin to plug our -4 in, we find out that it does turn out to be 7 equals 7, which is true. However, the next one's going to be, since the next one is false, when we plug -4 in. then it's not going to be a solution no matter what. So you have two linear equations, you're given points. You plug those points in, and if it's true for both of them, if it satisfies this, so this is true and this is true, but if they were both true, then it's an ordered pair. If you plug a value in and only one of those equations are true, then there's no ordered solution. And obviously, if you plug a value in, they're both false. That's just self-explanatory. All right, son, I love you. Any questions? Hit me up.